So, we were looking at computing standard deviation. So, standard deviation is mean we have seen. Now, standard deviation is if the mean is, suppose the mean is represented by mu, then I take the sum of the deviation from the mean for every element of the array. So, the array was A with every element being called A I. So, what I am trying to do is I am taking the difference of A I from the mean, and since the difference can be, suppose there are some values and this is the mean, and the value can be a little away from the mean on this side, more than the mean or less than the mean. So, we take the square of the mean, square of the difference, and I do that for all the elements I equals 1 to n, right, and then I take the square root of the whole thing. That is my standard deviation, okay, or my variance. So, I can compute either this or this, whatever I like. So, you will simply understand that in the code that we have given a little earlier, then there we had computed the mean, that means mu has been computed, which was the average that we computed last time. So, if I have read the elements in an array, whatever the elements are 5, 7, 3, 2, and I have computed the mean, mu has been computed, mean is 12, 315, 17 divided by 4. So, it is 4 point something, 4.1, 4.25, right, that is my mean. So, now for every element again in this array, I find out for I assigned 0, I less than equal to 3, I plus plus. What do I do? For every element I have got the mu, and let us call it average, right. So, sum was 0. What does it look like? Sum was 0, sum will be now sum plus I am getting sigma of mu minus A I whole square. So, sum plus average minus A I times average minus A I, all right. So, that is the square, average is mu minus A I, that is. So, I am doing this square and I am repeatedly doing this and getting the new sum, and at the end of this loop therefore, I have got this. So, I can say STD, it is a dev, let me call it standard deviation, is square root of the sum, all right. In that way I can find out the standard deviation also. Now, let us come to the now what is the application, what is the meaning of this. So, with these say in a class you are supposed to write a program where you want to find out, say in a class of physics, what is the average of the numbers of all the students. So, I will find out the mean and mean of the class marks, right. Similarly, I can find out that what is the standard deviation, how much did it vary, that also I can find out. Now, let us look at this another problem. Say a shop stores n different types of items, n different types of items. Now, given the number of items of each type sold during a given month and the corresponding unit prices compute the total monthly sell. So, what is the scenario? The scenario is this. I have got say 5 items. Item 1, item 2, item 3, item 4 and item 5, and let me call it the item, let me call it on this side, let me call it, this array is item price, item cost. Item cost. Suppose the cost here is 7.5 rupees per item of type 0, 25 for item of type 1. This is 0, this is 1, this is 2, this is 3, this is 4. So, the item cost for this, for item of type 2 is 12.5, item of type 3 is 10, item of this is item of type 4 is 50 rupees. Now, I want to store how many items of each type has been sold. So, I take another array and call it items sold. Suppose 5 items have been sold of type 0, 6 items here of type 1, 2 items of type 2, 4 items of type 3 and 2 items of type 1. Now, my question is, what is the total sell? So, what should I do? You can easily understand that here is the item cost. So, I have to multiply this with this with this and add all these costs. So, it will be 7.5 times 5, it will be 7.5 times 5 plus 25 times 6 plus so on and so forth. In that way I can find the total cost. So, what will the program look like? The program will look like I will be needing 2 arrays, item cost and item sold, and they should be of the same size, assuming that I know beforehand that there are 5 items. So, I can start with item cost of type 5, but this will be cost will be of type float, and there will be another, the number of items is items sold, the number of items sold is integer. So, I will have this. I am not showing the part that here I am reading the 2 arrays. So, after I read the arrays, I will have 2 arrays like this. One is an integer array, another is a floating point array. This is a float and this is an integer. Now, my actual body of the program will be in a loop for, say I am doing it using for, say I assigned 0, I less than equal to 4, since the size is 5, I plus plus, and what do I do here? What do I do in the body of the for loop? I take okay. I write actually only one statement will do. There is no harm in putting this bracket. Total cell, which was a variable of type float, total cell is total cell was initialized to 0, total cell plus item cost I times multiplied by item sold I. So, this will be done in a loop, and so I will take the first item cost 0, multiply with that with item cost item sold 0, add that with the total cell which was initialized to 0. So, here I can have float total cell initialized to 0, 0.0. All right, I can do that. So, now I am doing it in a loop. So, first I multiply these two, add it to total cells. Next, again in the next iteration I is incremented, I take these two and multiply them and add it to the total cell. Then I do this two and multiply them, add it to the total cell, and I go on in this way. This is in this way, by using this array I will be able to add all these values and I will get the total cell at the end. So, here we could see two very nice examples of application of arrays. Okay. Now, another problem that I gave you, I mean, is I was while comparing the arrays, you can do it in multiple ways, that there was two arrays, you must have solved it by now. That there were two arrays like this 7, 7, 5, 5, here 6, here 4, but again 3, 3. So, everywhere they are matching, but intermediate they were affected, and I had a flag value. So, flag was initialized to 1, and then in a for loop I was checking, this was A and this was B, flag was initialized to 1 if AI is equal to BI. This I can do because here I am doing it element wise, then flag equal to 1, else flag equal to 0, and I can do exit and I come out of the loop straightway. I come out of the loop, because it does not really matter at which position the mismatch occurs. As soon as a mismatch occurs, I can say that flag is 0, and so I come out. So, when I was comparing this, whenever I find a mismatch, the flag will become 0 and it will not be reset to 1 again because of this match, because this part is not being computed. I need not compute it. I need not compute it because my objective was to see if the two arrays are equal, and here the violation has already occurred. So, they are not equal. Okay. However, so that is one way. You can try it with while loop also. You can try with while. To solve the same problem. Another point is here that time and again here, everywhere I am setting the flag to 1. I could have changed that also here, if what did I need to do? I go on, I have set flag to 1, and the condition I simply change. I just change the condition. If ai is not equal to bi, then make flag 0 exit. I could have done this. As long as this condition is not holding, I am going on doing the loop. Is it clear? I will go on doing the loop as long as there is no mismatch. This condition means mismatch. As soon as there is a mismatch, I will set the flag to 0 and exit. This is another way of solving the problem. So, you have to think logically what exactly you need to do and what exactly you are writing, what is the flow and what is happening with the variables. And I always suggest that you have small pictures of the different variables and see how they are changing in the course of running the program. Okay. Now, so we have seen a useful commercial, so called toy commercial problem, that how I can find out the cost of total sales or monthly sales. Okay. So, and here the number of items sold per month are given, then you can do it. Okay. Well, next let us look at a very important thing called searching. Searching is a fundamental task in any and in fact, in many computations. In many computations we need to search. What do we search? There are different types of searches, but we will be now talking about the simplest possible search. That is, we are trying to find out whether a particular element is there in an array, right. Say, so the purpose is to check if a given element which is known as the key is there in the array or not. We will first talk about the array is not arranged in any order, and we will do that. So, suppose I ask the question that is there any even number in the set of numbers given? Suppose there are some numbers given 5, 7, 2, 9, 1, 8, 3, like that. I want to see, and suppose this is a huge, this is a list of 100 numbers. I want to find out whether there is any particular number, forget about even number for the time being. For the time being, let us assume that I want to see whether in this list any 4 is there. Is there any 4 in the list? That is the question that we are asking. The answer can be either yes or no. If it is yes, then the next question comes, where in the list is it there? Is it? Where means in which position it is there. I may like to know the position, or I may not like to know the position. I will be satisfied to know whether this list contains any 4 or not. All right. So, 5, 7, 2, 9, 1, 8, 3. So, again 5, 7, 2, 9, 1, 8, 3, and my key is 4, because I am interested in the existence of 4. So, instead of writing the C which you will be writing, I will be discussing how to approach this problem, what would the pseudo code be. And I am sure in the assignments, in your practice, you can write the program. So, I know I need to know beforehand this list. So, I need to know a list which may be an integer list of might be here 7 numbers. I need to know that. Also I need to know which key I am searching for. Once I know these two, so I know 5729183 is my list and I know that 4 is my key. Then how should I go about it? I have got 4 in mind. I start to look at as if I am looking at through some means at different positions. I look at this position and check this element and compare this element with the key and I ask, are they equal? If the answer is yes, then obviously I can say that 4 is in the list. But as you can see, it is not true. So, in case of no, I will shift my focus from here to here and I will now compare with 4 this element 7. Are they equal? No. Then I will again shift the focus and I will go on shift the focus and I will compare with this element with the key. All right. In that I will go on. How long shall I go on? Till the end of the list. If suppose here there was a 4, instead of 1 there was a 4 here. Okay. Suppose instead of 1 there was a 4 here. Then when my focus changes to this point and then again comes to this point and then I find that this element is matching the key value, then I can exit and say yes, 4 is there in the list. Then if the other question has to be answered that okay, 4 is there, but where is 4? Where is 4? In that case what would be your answer be? Your answer would be this position. And what is this position? This position is nothing but the current index, current value of the index. Here the index started, this is my index which was shifting. So, now we can think of the algorithm. I have got 5, 7, 2, 9, 1, 8, 3 and my key is 4. So, I will be doing, so this is a loop which is list for I equals 0, that means the focus or the index I less than equal to 1, 2, 3, 4, 5, 6, 7, 6 I plus plus, I plus plus if list I, that means the ith element of the list is equal to the key, then I can say found assigned 1. And what is found? Found is some variable which I have initialized at this point. Initially nothing is found, it is not found. So, found is 0 initially, I have not found the key. Here I am comparing, as soon as I compare, I put found equal to 1, and then I can exit, or this automatically this loop will go on. Now, if I do it in this way, what is the problem? Suppose my key was 1. Then it goes on I 0, this is never happening, found is still 0, it goes on, it comes to here, and I come to found equal to 1, and then I can say if found equal to 1, I can printf key found at position %d I. So, at that point I can also print that it has been found here, right. In the worst case, what can happen? Found will remain 0, found will remain 0, and I will come to the end of this point. When I come here, I can check if found is 0, printf key not found. Okay. If I do not find it, there can be different flavors of the same problem. The other flavor could be that suppose this element 1 is there at multiple places, suppose it is also here. Then what will this program result in? What would be its output? I will go on checking here, I will check the for loop is extending up to which part? The for loop is extending up to this position, and this is separate. I should have written it on this side. So, I go on checking this. So, key is found at position number 0, 1, 2, 3, 4. Key is found at position 4. The list is not exhausted. Ultimately, it will come to this point, and again it will say the key is found at position 6. Twice it is found, it will be told like that. Okay. Keys it will print twice. If at the end it comes and still the key the value of the variable found is 0, then it will say print it is not found. I could have also say the same thing, same problem I do, say suppose I have got a list 5, 7, 9, 2, 1, 3, 1. The question is how many ones are there? The same algorithm will do, the same algorithm will work, right. What is the same algorithm? The algorithm is I start from one point from this beginning. Let me draw it in this way. If this be an array where all my elements are there, five, 7, 9, 2, 1, 3, 1. I start from the beginning I equals 0, and for every element I compare with the key and go on till the end. Now, if I want to do this, What is the additional variable that I will require? I will require another variable count, which is initially 0, other than found, which is also false. So, whenever I find a 1 and my key is 1, so whenever I find a 1, I will say found is equal to 1, and also I will do count plus plus, and I will continue. Here I come and I will find I will have the value of count to be 2. So, I can also, so I can say that here I could print where found is becoming 1. So, I can also say at which position it is found and how many times it is found. Now, it can, another flavor could be that I have got this, say this array, I have got this array, and some array 6, 3, 2, 9, 1, 5, and whenever I have been given a key, say the key is 2, as soon as I find 2, that is enough for me. I just want to know whether 2 is there in the list. I am not interested to know how many times it is there, or in which position it is there, or at best I may like to know at which position you found it first. So, what I can do, I will go on searching like this, and whenever you find 2, then you print that I have found 2 here and exit. So, what will you do? The loop will be the loop, inside the loop you will have, you can do it like this, that if a I or list I, I was writing list I is not equal to key, all right, for, you could have done it by while also. N minus 1 I plus plus, you go on doing this. If list I is not is sorry is, if it is equal to the key, what have I done? Is equal to key, say found equal to 1 and printf the position and exit, and you need not go through the entire loop. Now, there are, so that is this sort of search which I am doing in a linear way from one side to the other is known as linear search. It is a simple, very simple search for a particular element. Okay. We will see a little bit more on this in the next lecture.